This video is going to explain how to set up the two sound experiments. We're going to start with part A, which is finding the frequency of a tuning fork and comparing it to its stamped frequency. This lab uses a microphone, and you need to plug it into the ULI box. This is the interface between the probes and the computer. You need to make sure that this is turned on, so that the green light is on. The on switch is on the back, and if that doesn't seem to work, make sure that it's actually plugged in. You're going to plug the microphone into DIN number 1, and this needs to be plugged in before you open the program. The program that we're using is Logger Pro. Be careful, we have two versions installed. Do not click the link for Logger Pro 3 point whatever it is on the screen. That will not work with our interfaces. Okay, so what you need to do is open the Jarvis Collegiate folder and go to Pickup, and then scroll down to Physics. And you're going to open the Logger Pro 2.2 executive file. There's a folder that says Logger Pro 2.2 files. Don't go in there because otherwise you will open up the file in French. It works fine. If you want to work in French, work in French. When you first open this up, usually you will get some buttons that say COM and then scan. They say OK. Just keep clicking OK until you get to this screen. So we're going to go to File and then Open. Now we're going to go into the Logger Pro 2.2 files, and we're looking for probes and sensors and then microphone, and then we're clicking on microphone. And then we're going to click Setup and then Data Collection, and we're going to change that to Real-Time Collect and press OK. And that's all we need to set up for the first lab. You can just check that it works, press Collect, and you will get some nice, beautiful data. This is not what we're looking for the first part of the lab. We are going to start with a tuning fork, which will give us a nice, simple wave. So be careful when you do this. A tuning fork, when you hit it, it vibrates this way. So when you place it next to the microphone, you're going to hold it this way or this way, but not that way, because then the waves will just be going out to the sides and not going into the microphone. And then you'll just get junky data. When you're hitting the tuning fork, you're going to always hit it with a hammer. You never hit it on anything hard. If you don't have a hammer, you can use a bone, like your knee or your elbow.
This kind of hammer, one side is hard, one side is soft. You want to make sure you're hitting it with the soft side.
Generally, the best way to work this is to have one person start the tuning fork, so they hit the tuning fork and then they hold it to the microphone, and then one partner will press Collect. You should get a fairly sinusoidal wave. It may not be very smooth, it may be a little jaggedy, but that is generally okay. If you get something like this, then there's a problem and you're going to need to try again. Sometimes this happens because you've plugged the microphone into the wrong outlet. Make sure that you're plugging it into DIN 1. And don't worry if you need to do this a few more times. I had to do it a whole bunch of times, and I know what I'm doing. Once you have your data, you want to try to fit it to the screen. We're going to use this Fit to Screen button. It's this A button over here. You need to find the time for 4 cycles, and the easy way to do this, if you look in the lower right-hand corner, so those are the X and Y coordinates. In this case, our X is time. The Y is sound pressure, but we don't really need to worry about that. Pick a beginning and an ending to your wavelength that is easy to read. So if I were to pick this one here, I'm not suggesting you do, just using it as an example. When you find the end to your 4th cycle, then you want to make sure that you go right to the same point. You can obviously use crests, or this would be areas of compression instead. That's up to you. So there's a couple of ways you can get this data. You can either just look at the values and then move over and look at the values and write them down, or you can click and drag. If you click and drag, if you look down in the lower right corner, you'll see a DX. That is your time interval. So we're not doing this for 1 cycle. Of course, you're going to be doing this for 4 cycles because that way you can reduce error. I'm not going to show you how to find the 4 cycles.
And if I can go beauty vlogger here for a second, you're going to compare your frequency, calculated frequency, to the stamped frequency on the tuning fork. Okay? Then you're going to do this for another tuning fork, and then you're going to do it for a mystery sound. And the mystery sound could be you singing, as I did before, or whistling. I'm not a great whistler, but let's see how this works.
Yeah, so it turns out my whistling wasn't up to snuff that day, so I sang instead. And you'll notice that we no longer have that nice pure sinusoidal wave of the tuning fork. You will still want to get the time for 4 cycles. That means you're going to have to figure out what a cycle is for this more complicated pattern. And that is how you do part A of this lab.